Hello and welcome to Chemistry with Dr. Clark. In this video I'd like to talk about naming and writing the chemical formulas for molecular compounds, molecules. Now, the easiest way for you to identify that you have a molecule is that it's going to be something that is only composed of nonmetals. Okay, if you're looking at things that are ionic compounds have a metal plus a nonmetal. If you're looking at metallic compounds, they would be composed of only metals. But if you have something that is made up of only nonmetals, then you have a molecule. And the bonds here are all formed because the electrons are being shared, right? So if you have two atoms that have come together, there's going to be a sharing of electrons in between them. Now, the way that this was going to work is that you're going to name the first element exactly the way you'd see the name on the periodic table. So if the first element is oxygen, it gets named as oxygen. If the first element is sulfur, it gets named as sulfur. The second element, though, is going to change its ending to "ide." So if the second element is chlorine, it becomes chloride. If the second element is bromine, it becomes bromide. It's meant to make this a little bit more consistent with the ionic naming, because in ionic naming, the metal name in the beginning does not change, but the nonmetal name in the end does change to "ide." Okay, so it becomes a little more consistent that way. But for this one, you do have two nonmetals. The first one's going to be nonmetal. Second one is also going to be nonmetal. The first nonmetal will not change its name. The second nonmetal will. Okay, and for these here, you do have to say how many of each atom you have. Think of carbon monoxide versus carbon dioxide. In a molecule, you can have a molecule that's made out of the same atoms, but just different numbers, right? Carbon monoxide has carbons and oxygens. Carbon dioxide also has carbons and oxygens. What makes them different is the number. And for molecules, there's no way to predict the number of each atom unless you're told. Like if I wanted you to know that there's two oxygens, I have to tell you that there's two. If I wanted to tell you that there was only one oxygen, then I've got to tell you that there's only one. Okay, and the way that we're going to tell you how many of each atom you have is by using prefixes. The prefix for 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Now, I cannot stress this enough. You need to sit down and you need to memorize them. Naming molecules is going to be extremely difficult if you can't remember the prefixes. Now, some of them are going to be easy, like 3 and tri. Think tricycle, right? A tricycle has 3 wheels, tri. Or deca, a decade. If you have a decade, that's 10 years, 10. Octa, like an octopus. An octopus has 8 tentacles. Okay, so some of them you will remember. Some of them are a little unusual and we don't use them a lot, like hepta for 7, or nona for 9, or tetra for 4. Right, so a few of them are going to be a little harder to remember than others, but you really need to sit down and memorize them. Can't say it enough. Okay, so I guess the best way to do this is by example. Okay, so let's pull out a periodic table. I have one hiding here in the back. Now, this periodic table is a little bit smaller than normal because I've removed all of the B elements, because the B elements are all metals. And if you're talking molecules, molecules are all about the nonmetals. Now, your periodic table will have a staircase, right? It's usually a dark line that comes down through the table. And what it does is it separates metals from nonmetals. So these over here are my metals. I'm not going to be using any of these in this video because we're talking molecules. These over here are your nonmetals. Okay, everything on this side of the staircase. So when I write about these molecules and I name them and I write the formulas, everything is going to come from this side of my periodic table. You've also note that I've got all of my prefixes written here so that way I have them if I need them. Now the way this works You're going to name each of the two atoms, and you're going to tell me how many of each. And that's it. Now, if you have done naming of ions, and if you've watched my videos on how to name ions, you know that ions are all about finding charges and then switching them. Okay? There is no switching with molecules. No switching. The switching happens with ions, but it does not happen for molecules. So for this one here, I'm literally going to tell you that there's 4 of the phosphoruses and 8 of the oxygens. Right? So it's going to be 4 with the phosphorus, 8 with the oxygen. No switching of numbers, no anything. Okay, so what's the prefix for 4? Prefix for 4 is tetra. So this is going to be tetra. If you look up P, the symbol P is phosphorus. And remember, the first name doesn't change. So this will actually be written as phosphorus. So phosphorus. There we go. Okay, let's do the second element. There's 8 of them. The prefix for 8 is octa. So this is octa. And O is the symbol for oxygen. Now the first element did not change its name, but the second one does. So it won't be oxygen, it'll be oxide. So tetraphosphorus octaoxide. All right, let's move on to the next one. I've got 2 of the I's and I've got 4 of the O's. To tell you that you have 2, we're going to use di. So this will be di. I is the element iodine. So diiodine. First word doesn't change its ending. Now, we've got 4 of the O's. Prefix for 4 is tetra. So this will be tetra. And the O again is oxygen, and we do change its name to end in ide. So tetraoxide. Right? Easy peasy. There's no switching, there's no charges. All you literally have to do is tell me how many and the name. How many and the name. That's all you have to do. So we move on to the next one. There's 2 of them, so that's a di. S is the symbol for sulfur. You keep the name the same, so sulfur. And 4, use the prefix tetra, so this would be tetra. And F is the symbol for fluorine. Now it is the second name, and the second name does change to ide. So this would be tetrafluoride. Now I think at this point it's probably good to make a couple of notes. First off, if you have your periodic table in front of you, then you really shouldn't get the spelling wrong for any of these names, right? If you are being conscientious and you want to show that you're working hard and that you are concerned with the quality of your work, you need to be able to write the name of the element correctly. No spelling mistakes, okay? If you have spelling mistakes, 1 or 2 in an entire worksheet, that's not bad. But if every single element that you write is spelled incorrectly, what it's showing is that you don't take care with your work, and it gives a bad impression, right? You would like whoever's reading your work to say, yes, see, it's all spelled correctly. They were taking their time. They were focused on doing a good job. The other thing is no capital letters. The names of molecules, the names of ions, the names of compounds, the names of any of these, none of them have capital letters. If you put in capital letters, that would be incorrect. Okay, they have to be lowercase letters. Now, the other thing I should point out, maybe we'll get to an example here in a second. Let's say that we do this one. Okay, 2 is di, so that's a di. N is the element nitrogen, so that is dinitrogen. You got 7 of the Cls. 7 is an unusual prefix. It's part of the reason why I put this example here. Because if you got 7, it's a hepta. So it's a hepta. Cl is chlorine, but the second name does change to ide. So this would be a chloride. So a dinitrogen heptachloride. Alrighty. So we move on to the next one. You have 3 of the H's. 3 is tri. So that's a tri. H. H is hydrogen. Now, hydrogen's a bit unusual. We do have all of our nonmetals put over here on this side of my periodic table. Hydrogen is over here hanging out with the metals, but hydrogen is a nonmetal. So if we move this up, H is hydrogen, so this is a trihydrogen. Name change doesn't change for the first one. Now, if you look at this, I've got 3 H's, but there's no number next to the P. If there's no number next to the element, you get to assume that there's 1, right? So there's actually 1. In the world of chemistry, we're lazy people, okay? Concise, I guess, would be the better word, but it's laziness, right? If I tell you that there's a P, you have to assume that there's at least 1, because why would I go to the trouble of saying P if there was none of them, right? So if there are 1s in chemical formulas, we do tend to leave them out. So if there's 1 of these, that means I have to use the prefix mono. P is the element phosphorus, and the ending will change to phosphide. So this would be monophosphide. There we go. Now, this one you should recognize. CO is carbon monoxide, right? It's one of those gases that if you burn wood, you have to be careful of because carbon monoxide is poisonous. So if we were to take a look at this, there's no numbers, which means that really there's 1 carbon and there's 1 oxygen. Now, if there's 1 of each, I should use mono. Okay, so this should be, and let's write it on top. Mono, C is for carbon, so monocarbon. And there's only 1 of the oxygens. So it should also be mono. And instead of oxygen, it should be oxide, monoxide. Now, this is where we get into talking about a few things that we do to make our lives a little easier, make things sound better. Okay, the first rule is, let me put it right here. The mono prefix has to be used on the second element. Like here, when I had trihydrogen monophosphide, I have to keep mono on the second element. But if mono is on the first element, we're allowed to drop it. So instead of calling this monocarbon monoxide, you're allowed to drop the mono from the first one. But it's only true for the first element. You are not allowed to drop it from the second element, but you are allowed to drop it from the first one. So really, I can rewrite this as carbon monoxide. Okay. Now, let's talk about the second little thing here. When I read these out, I've got octaoxide, tetraoxide, I've got monoxide. The prefix and the element itself really do get chopped up, right? So there's a second thing that we like to do. If your prefix ends in an O or an A, and the very first letter of your element is a vowel, we tend to drop the O or the A. That's why instead of it being carbon monoxide or monooxide, we like to drop this O here. So if your prefix ends in an O or an A, and your element starts with a vowel, you are allowed to drop the O or the A. So this really would become carbon mon, right? We drop the O, oxide, carbon monoxide. Now we can do the same thing up here. When we had octaoxide, if you have a prefix that ends in an A or an O, and the element starts with a vowel, you're allowed to drop the A or the O. So instead of a tetraphosphorus octaoxide, you could call it just octoxide. Or for this one here, right? Tetra ends in A, oxide starts with a vowel, you are allowed to drop the A. So you could call this tetroxide. Okay, it's meant to be so that it rolls off the tongue a little easier. So diiodine tetroxide. Instead of tetraoxide, it's tetroxide. This one, yeah, I like that. That's not bad. Or this one, right? Carbon monoxide becomes carbon monoxide. Again, rolls off the tongue much nicer. This one here, though, the octoxide, that just sounds weird to me. So for this one here, I probably would not have dropped the A. I would have probably left it as tetraphosphorus octaoxide, just because it sounds nicer. And that's the problem with some of these naming rules. The rules are not carved in stone, right? They have a little bit of leeway to them. So when you write them, you should often say them to yourself and say, well, would it sound better with that A dropped, or would it sound better with the A left in? Octoxide or octaoxide? It's kind of a toss-up. This one, though, here, definitely, monoxide is definitely better than monooxide. Okay, so those are two things. The first one here, there's really no negotiation on this. If the prefix on the first element is mono, then you definitely got to drop it. This one here, though, is more of a usually, right? If your prefix ends in an O or an A, and the chemical that you have begins with a vowel, you're allowed to drop it, but you don't have to. This would be one of those, you go with what your teacher or whoever is giving you the problems wants. If they want you to follow this rule to the letter, then you just drop all those O's and A's. If they give you some leeway and allow you to listen to the sound, octoxide, octoxide, then you get to choose. Now, it only works for O's and A's. You'll notice here I have a diiodine. Those two I's do stay together, so they're always going to be a diiodine. Okay? So it really does depend on your situation. Now, let's skip these next three and go directly to the opposite. What if I give you the name and I would like the chemical formula? Again, no switching around. I'm literally telling you these are the two elements and this is how many you have. So if I'm talking about dibromine, di means I have two. I just need to look up the symbol for bromine and say that I have two of them. So bromine has a symbol of Br, and there's two of them. Tetrafluoride. Tetra means I have four of them, and I just have to look up the symbol for fluoride. So fluoride would be here. Okay, in the periodic table it's listed as fluorine, but remember the second one changed its name, so fluorine and fluoride go together. So the symbol is an F, and 4 means you got 4. Now, if you do think back to ionic compounds, if you had something that was 2 to 4, you would want to reduce that to 1 to 2, right? We always take ratios and bring them down to lowest terms. But in the world of molecules, we don't do that. You literally tell me how many you have, and there's no reduction. So it would stay as Br2, F4. It would not reduce to Br1, F2. That only works for ions. Same thing with the switching of the charges, right? The switching thing only works for ions, not for these. All right, if we talk about pentaphosphorus, penta is 5, so I know I have 5 of them, and the symbol for phosphorus is P. So that'll be a P5. And I've got an octachloride. So chloride was originally a chlorine, but the name changed. And octa means I have 8 of them. So O8. Writing the chemical formulas for molecules has got to be the nicest thing of all the naming, because it tells you what you have and how many. So if I take a look at this next group, I've got a carbon. Symbol for carbon is C. Now, there's no prefix out in front telling me how many. If there's no prefix on the first one, you have to assume it's mono, because that's the only prefix that you're allowed to throw away. Right? You're allowed to drop the prefix mono on the first element. So that means I got 1. Now, I can write the 1 there, but you also know that in the world of chemistry, if you've got 1 of an element, we don't like to write that down. So I'll get rid of it in a minute. Tetra means 4, and the symbol for chloride is based on chlorine, so it's Cl. So Cl4. So if I drop my 1, this would be a CCl4, carbon tetrachloride. If we move to the next one, dihydrogen. Symbol for hydrogen is an H. Di just means 2. Monosulfide. Now the ending changed to "ide", so it was originally a sulfur. That's an S. And mono means 1. Now I can put the 1 there, but we don't usually put 1s in our chemical formulas. So for this one here, it'll just be an H2S. Notice how I didn't drop the mono. You can drop the mono off the first element, but you can't drop it off the second one. All right, and if we take a look at the last 2, I have a nitrogen pentoxide. Again, there's no telling me how many nitrogens, so there was a mono here that was dropped. The symbol for nitrogen is an N. Pentoxide, you'll notice that they dropped the A. It could have been a pentaoxide, but because the prefix ended in an A or an O, and the element started with a vowel, they dropped it. So it was just pentoxide. Oxide comes from oxygen, that's an O. And pent is penta. So there's 5. And if we look at the very last one, I've got a disulfur tetraoxide. So disulfur, sulfur is an S. Di is 2. Tetraoxide, oxide comes from oxygen, so that's an O. Tetra means 4. And again, you do not reduce this to lowest terms. You would not reduce it to 1 to 2. For molecules, you go with what you have. And again, if I point out the name here, the tetra ended in an A. The element started with a vowel, so if I had wanted to, I could have dropped that A and called it tetroxide. Or I decided that tetraoxide sounded better, right? There's some leeway there. So I'm hoping that this helps you with your naming and writing chemical formulas for molecules. They are quite straightforward. The biggest thing is do not mix them up with ions, right? Ions do a weird switch thing. They take the charges and switch them. You don't do that here. If the penta goes with phosphorus, then the 5 goes with the P. If the octa goes with the chloride, then the 8 goes with the O, right? There's no switching. There's also no reducing, right? 2 to 4, 2 to 4 stays as 2 to 4. You do not reduce it down. So I'm hoping that helped. And as always, thank you for joining me here at Chemistry with Dr. Clark.